So it's been a while, but welcome back. I am going to do something different for today. Instead of going for something that is pretty general, I'm going to go through more K-BAT questions. Because sequence and series, AP, GP, and so on, sigma notation, I believe that those are easy enough for me not to teach. I believe that if the teacher explains slightly, you should be able to get it. But I'm certain that most people might not completely understand how to do some of the K-BAT questions that come out. The reason why I'm bringing up all of this is because all of these are not AP or GP. If you look at the numbers, they don't go up in a with a ratio or in a or with a common difference. They go up in more of a curve thing, and we got in more of a weird pattern. So they aren't AP or GP. So you cannot use SN punya formula. You cannot use n over 2 2a plus n minus 1d, or you cannot use a bracket 1 minus r power n bracket over 1 minus r. However, there is a few ways that you can use to play with the numbers, so you can apply the formulas instead. So you can apply the formulas in another way to help with the answer, but it's not the complete answer. You need to play with the numbers a bit to find out the sum of the first n terms. So I'm going to go first with A. So you see A is 1 over 2 plus 2 1 over 4 plus 3 1 over 8 plus dot 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 dot. So as you probably notice, there are two separate areas. There's the 1, 2, and 3, and then there's the 1 over 2, 1 over 4, and 1 over 8. So if you notice here, 1, 2, and 3 are APs. So and 2, 4, and 8 are 1 over 2, 1 over 4, and 1 over 8 are all GPs. So you can split A up into A 1 plus 2, because remember, it's 1 plus 1 over 2 plus 2 plus 1 over 4 plus 3 plus 1 over 8 plus dot 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 dot. And then using the AP or GP formula for general term, Tn is equal to n for if you separate properly, you will get this 1 plus 2. I'll take this one out first. I'll group them up in one area. So 1 plus 2 plus 3 plus dot 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 dot. The last term would be n, because it's 1, 2, and 3, and there are n terms in this. So the last term here will be n. So n, and then plus 1 over 2 plus 1 over 4 plus 1 over 8 plus dot 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 dot. And then the last term here will be 1 over 2 power n. Because the reason why I know it's one, how do I know that it's 1 power 2 over n? Because this is 2 power 1, 2 power 2, and 2 power 3. So 1, 2, 3, 4 until n terms. So the last number is 2 power n. So now I have an AP and I have a GP. Together, when they are combined together, they don't form an AP or a GP. But when I separate them, I can separate them into an AP plus a GP. So this is 1 over 2, n over 2, n plus 1, and then plus this one is 1 over 2, and then 1 over 2, 1 minus 1 over 2n over 1 over 2. So I can cut this one off. Then you will get n over 2, n plus 1 plus 1 minus 1 over 2n. And then I believe you can continue solving it. So you can stop it. You can stop it by here already. This is supposed to be your final answer, because since it involves 2 power n, it's very hard to actually complete the thing. So that's for A. How about for B? 4 plus 4 4 44 plus 44 4 4 plus 4 4 4. For example kan, if it's something like 0.3 plus 0.33 plus So the question that you might be thinking of is 0.33333, and then you'll get 0.3 plus 0.03 and so on. This one is a bit different because it doesn't involve decimals, it involves whole numbers. So the first thing you have to do is 4 plus 44 plus 444 plus dot 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 dot. And then what you have to do is you have to factorize the common factor, which is 4. So I will take out 4. That will be 1 plus 11 plus 111 plus 1111 plus so on. And then the next thing that you will do is convert them into fractions with the term 9. And I'll tell you why later. So 1 is equal to 9 over 9. So it's 4. 9 over 9 plus 29 over 9 plus 999 over 9 plus 9999 over 9 plus so on. And then you will get you take out the 1 over 9, so it's 4 over 9, 9 plus 99 plus 999 plus so on. And then you might be thinking, what does this actually do? How does this actually help us get the answer? So you will know that 9 is equal to 10 minus 1 and 99 is equal to 100 minus 1, and then so on and so forth. So if I were to put that in our formula, then it will be over 9 and then 10 minus 1 plus 100 minus 1 plus 1000 minus 1 plus so on. So you will group up all the minus 1 together. So if you group up all the minus 1 together, then you will get n terms. So minus 1, minus 1, minus 1. And remember, there are n terms. So since this minus 1 appears n times, because there are n terms, then we can put minus n at the end. And then it will be 10 plus 100 plus 1000 plus so on minus n. Now, remember, there are n terms here. Since there are n terms, and then this is a GP, because 10, 100, and 1000, the ratio here is 10. So with that, we will get 4 over 9, 10, 10n minus 1 over 10 minus 1 is 9. So 9 minus n. And then e minus n. Okay, and after that, now that I took that one out, then in the end you will get before that 4 over 9. I'll multiply this one in because it's the same term. So 10 n plus 1 minus 10 minus 9n over 9. And then in the end, I'll multiply it. So 4 over 81, 10n plus 1 minus 10 minus 9n. And that's your final answer. So for this one, we separate them into an AP and a GP. And we know that this thing there are n terms in here. So we use n as the final term. So here is n, here is 1 over 2n. And then similar here, where we take out the common factor, which is 4. And then we divide them by 9. So you will get 10 minus 1, 100 minus 1, and so on. The minus 1 repeats n times. So you can put minus n at the end. And then the remaining number, 10, 100, 1000, and so on, it makes a GP. So you can use the GP formula, the SN formula for GP, and you will get the answer. How about C? C is different. So for C, we want to let SN be this term. So let SN equals 3 over 2 plus 5 over 2 square plus 7 over 2 3 plus dot 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 plus 2n plus 1 over 2n. So sometimes they won't give you this, but if you know that this thing is a GP, 3, 5, and 7 and so on form GP, AP I mean, and 2 power 2, 2 power 3 so on form a GP. So even if they don't give you this final term, you should be able to find it yourself. Then the answer will be 2n plus 1 over 2n. I mean the final term. Oops. So after you find out your final term, this one is slightly different. You cannot there is not there's no obvious way to put them in a way to turn them into separate GPs and APs. They are interconnected to each other, so they cannot form as a solo GP or a solo AP, unlike question A. But since they're divided, it's not plus, so you cannot separate them by plussing. You have to they're divided. So what you can do is you want to play with the numbers a bit. So what I recommend to do is there are two things that you can do. Either you multiply by 2 or you divide by 2. The hint that I will give you is, if the first number here is a whole number, like 1, normally if it's 1, for example, what I would recommend you to do is to divide the thing by 2. So it'll be Sn over 2 equals to 1 over 2 plus 3 over 4, and so on. But since we're not dealing with 1 here, we're dealing with an over 2 first. So instead, what I prefer to do is to multiply the whole thing by 2. So 2Sn equals to 3 plus 2 over 2, 5 over 2 plus 7 over 2 square plus 9 over 2 cube plus so on. And then plus since I multiply the whole thing by 2, the power here reduces by 1. So it will be 2n plus 1 over 2 power n minus 1. Again, remember, because I'm multiplying it by 2, so 2n, since it's divided, 2 over 2n is 2 power n minus 1. So, okay. Now you got that out of the way. Notice a pattern. 3. If I put these together, and then these together, and then these together, and all the way until here, so it's only 3 and this one left. Notice that they have the same denominator. And then notice that they both have the same difference. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. 2n plus 1 minus 2n minus 1 is 2. So with that in mind, we know that this whole thing, I mean this whole thing has a difference of 2 for each paired denominator. So if we do 2Sn minus Sn, or 1 or 2 minus 1, then we will get 3 minus 3 over 2 plus 5 over 2 minus 5 over 2 square plus 7 over 2 square plus so on until the last one would be 2n plus 1 over 2n minus 1 minus 2n plus 1 over 2 power n. So just take note, this is power. It's power. Okay. And then here is I know this one is 2n minus 1, but you don't have to ignore, you don't have to really do that, as long as you get the pattern on the way. So now you have a pattern until here. Minus plus minus plus minus plus. So you will get 3 plus 2 over 2 plus 2 over 2 square plus 2 over 2 cube plus so on, plus, since this is also part of the pattern, then you will get minus plus, so it will be 2 over 2n minus 1 minus 2n plus 1 over 2 power n. So you see, if you take out the 2, you will get a GP. So you will get a GP. So it'll be 1 over 2 plus 1 over 4 plus 1 over 8 all the way until 2n minus 1. So there are n minus 1 terms. So I'm going to immediately do the GP formula, but I recommend you to take out the 2 and then put it 1 over 2 plus 1 over 2 or 1 over 2 square plus 1 over 2 cube. So it's like 1 over 2 plus so on. But since I'm going to take a shortcut, I'm going to immediately turn it into a GP. So the first time is 1 over 2, and then 1 minus r power n. So it's 1 1 minus r, but there are n minus 1 terms, so you have to use 1 over 2 because the ratio is 1 over 2, n minus 1 over 1 over 2. Because 1 minus 1 over 2, right? So it's 1 over 2. So minus 2n plus 1 over 2 power n. So take it out of the way. Then you will get 3 plus 2. I'm going to make them the same denominator. So it's 2n minus 1 over 2n minus 1. And minus 2n plus 1 over 2n. And then I'll continue on. So it's 3 plus times 2. So 2 2n n minus 1 plus 1, so it's 2n minus 2 over 2n minus 1. How do I get n? Because 2 times 2 power n minus 1 is the power becomes plus, right? So it's 2n minus 1 plus 1, so it becomes 2 power n. And then 2n plus 1 over 2n. I want to make them the same denominator, so I'll multiply this thing by 2. So again, I'm gonna multiply it manually. So if you times 2, like that, 2 over 2, because it's 1, then you will get 3 plus 2n plus 1 minus 4 over 2n minus 2n plus 1 over 2n. So now you have the same denominator. Now I can actually combine them together. So 3 plus 2n plus 1 minus 2n, 4 minus 1, so it's minus 5 over 2n. So if you leave it like this, you will not get I don't think you'll get a full mark, because what you can do here is you can split it up. So 3 plus 2n plus 1 over 2n, and then a minus 2n plus 5 over 2n. It's minus 2n minus 5, but I took the minus sign out, so it becomes plus here. You can leave it in if you want to. Then 2n plus 1 over 2n. 2n plus 1 over 2n is equal to 2n plus 1, 2 power equals to 2 power n plus 1 minus n. So you will get 2. So it will be 3 plus 2 minus 2n plus 5 over 2n. So your final answer would be not 2n, 2 power n. So be careful of your powers. So it will be 5 minus 2n plus 5 over 2 power n. This is 2n, this is 2 power n. Know the difference. So yeah, it is quite long. But once you get the hang of it, you will get 3 marks. You will get 3, 4, 5, 6 marks for some of these questions. Because remember, this is a UEC based question, so it'll be more kebatish. So most of the marks are based on these things. So I recommend you to study these ones. So we got A, B, and C under the way. These the easiest one out of these 4 actually. So without further ado, let's get right into it. So for A, we separate them into their own AP and GP and then add them together. For B, we have a GP in the middle of everything. We have a GP in the middle of the question, but it's but multiplied by a random number, and then a minus n. For C, we have to multiply it by the denominator here, or divide, depending on, remember, the 1 at the front. If it's 1 over 2, then it's multiply. If it's 1 only, then it's divide. So so since it's over 2, I multiply by 2, and then I minus the new thing we got by the old one, and then we will get a GP. After we get the GP, then we solve the answer. For the last question, 1 squared times 2 plus 2 squared times 3 plus 3 squared times 4. Now, you'll know that 1, 2, 3, and 2, 3, 4 form your own APs. The problem here is this is squared and this is not squared. So again, we find the final term, Tn. So since 1, 2, 3 and there are n terms, so we know that this is n square. And then times, this is 2. This is T1, this is T1, T2, T3. T1 has 2, T2 has 3, and T3 has 4. So you don't have to use the a plus n minus 1d to find it, even though there's no wrong in doing it. It's just slower, and maths paper is very short time. So what instead I will do is, I will immediately know that this is n plus 1. Like this. And the reason why is because this is the first term, 1, 2, 3, so on. And then it starts with 2, 2, 3, 4. So if 1, 2, 3 until n, then 2, 3, 4 until n plus 1, because it's an extra 1 there. So Tn equals to n square, n plus 1. Now, we know that this whole thing is n square, n plus 1. So we can also express the whole thing as sigma. Sigma k square k plus 1, where k starts at 1 and it goes all the way until n. So
this is what I want to see.
From here, what you can do instead is you can multiply k square and k plus 1. So you will get n, k equals 1. Then you will get k square plus k cubed plus k square. And then using, if you remember correctly, this is about the special series with sigma notation. So we use these two, right? We use these two, but then they are plus together. But since they're under the same term, the thing you can do with this is you can separate them into their own. And then now you can apply the formulas in. So this one is n plus 1 over 2 squared. This is n plus 1 2n plus 1 over 6. So you add them together. I am not going to continue after this because everything else is just normal calculation, factorization. I'm not going to teach everything, but what I will say to you to do, if you want to do it, is you want to make sure that the numerator is the same, which is 12. I mean, it is 6 or 12. I think it is 6, but sometimes if it involves k cubed, k squared, and k, then it will be 12. Actually, no, this is 12. This is 12 because it's a 4. So yeah, you want to make the numerator 12, and then you want to factorize the common factor out, which is n and n plus 1. So this so be careful when you're factorizing it, because this is squared, so it's going to be n squared n plus 1 squared when you square it. So after that, then you will get n plus 1, and then a huge area here. This one you have to solve it by yourself, and then if you can factorize it further, then factorize it. If you can't factorize it, then you can leave it that way. But I'm not going to go further into it because that's a huge waste of time for me. Okay, this one, last one. The extra one is the easiest one to do. Find square root 3 square root 3 times square root 3 times square root 3 times square root 3. Square root of 3 times square root of 3 times square root of 3, and so on. So what you want to do is let x equal to that whole thing. So square root 3, square root 3, square root 3, square root 3, so on. Now, what you can do is you can square the thing, so x square. If you square, remember, if you square a square root, then you can remove the square root. So if you square it, then you can remove it. So it'll become 3 times square root 3 times square root 3 times square root 3, 3, 3, and so on. But remember, we're dealing with an infinite series. So this thing can go on and on and on everywhere. It doesn't stop because it's infinite. So if you think about it, if it's infinite, wouldn't this be the same as this? So this is x, so you can put it as 3x. So x squared equals to 3x. Then x equals to 3. This is very easy. This is the easiest one out. And this is the one that I like to do the most. It can work for every number that is not... every number that is... I think it can work for every number. But it will mostly involve 3 or 5 or 7. Because those are the ones that are irrational. But the absolute value, the sum to infinity, or just the sum of this whole thing, if it goes infinitely, would be 3. The reason why I can sub x in, even though I already times it, is because this thing is infinite. So basically, if it's infinite and this is also infinite, then do the same thing. I can really become x, and then I can get the answer. So yeah, I guess that's all. I just want to remind you that for these questions, you want to either separate them into your own AP or GP. You want to multiply if it's something like this, you want to multiply or divide the value by the denominator, so you can get a common difference, because 5 minus 3 is 2, 7 minus 5 is 2, and so on. For this one, you want to make sure that the numerator but then the denominator becomes 9, and you want to make sure that it's 1 plus 11 plus so on. Then you get 9 over something, because you want to get 10 minus 1, 100 minus 1, and so on, because you want to get this whole thing to become n, and this whole thing to become a GP. So and the last one is you want to generalize them into a general term, and then use sigma notation to use a simple solution for special series, which is this sigma stuff with k squared, and k cubed. And I guess that's all. Again, I'm not going to teach the basics, because those are, for me, it's a waste of time. I'd rather go to the harder ones, which I don't think a teacher can explain 100% understandably, very well. I mean, they can explain well, but it's very hard to understand. If you have any questions, you can ask me about anything regarding this chapter, or regarding anything for subjects. But do know that I might not give the right answer, so it's better to verify with a teacher after you get the answer.